Yes, hey fam, welcome back. Now I thought I'd go over what is Caesar hash, and Caesar hash is a really old way of hashing or encrypting. And as the name tells, it is believed to be used by the great Julius Caesar himself. And how it basically works is that, yes, consider this: you have A, and the Caesar hash has basically two things. It will have a key, and it will take the original string. And what we'll do is to that string for each letter, you will actually add the key value itself. So, for example, if you have A and you add one to it, it will become B. For A, if you add 2, it will become C, and so on. And it will loop around. Like, for example, when you're at Z and when you add 1 to it, it will not become the left curly brace, but it will actually loop back to A. Yeah, that's basically how it works, and it's actually really easy to implement. So, rather than wasting time, let's directly get into it. So what you have to do, and let's define the class. And the thing about this is that since it is actually not only easy to implement, but also easy to understand also. And again, the encryption and decryption both are like 90% similar, 99% similar with only one small modification. So you will have, and there's no need to initialize anything in this since we are directly taking the key string or the text and encrypting it and decrypting it. So yes, you will have to take to encrypt something and decrypt something. So what will take? You'll actually have the original text to be encrypted or decrypted, and you will have the key. And since this is being called inside a class, you have to have this self declaration over here. So now what? So now let's declare an answer to hold our actual answer. And so for each letter in the text, so what you have to do? Just think about it. If it is A, it has to become B. So you have to first convert the actual letter to ASCII value. So let's do that. So let's call it value. So in Python, how you convert is you use the ORD value. Like the converter is called ORD. So ORD of yes. And now just look at the ranges once. So yeah, now let's start with numbers. Numbers start at 0, which is at 48, and end at 9, which is 57. So if the value lies in between 57 and 48, if it lies between 57 and 48, then you have to make appropriate modifications so that you just get the range from the 0 to 9, and you don't want to like pass out to colon, semicolon, or something. And yeah, this is just a mathematical formula, and you can verify it once. So you'll take the value, and to value what you do, you'll take the original value, and to that you will add the key, and after adding the key, you will subtract it by the base value, which is 48 over here. And after doing this entire thing, you will mod it by the number of elements present in the range. So it is 49 to 57, which is 9. And after doing this entire thing, what you'll do is you will add it to the base value itself. So it is 48 plus value plus key minus 48 for encryption, and for decryption is just a negative sign over here. That's all it. That's why I told it is like 90% similar to it. And yeah, this is all it. This is how you do it. This is just a mathematical formula, and again, I'm telling you, you can just verify it by writing it out for other test cases. So else if the value lies in range, so now what? Now 2 for capital letters, so it should lie in range 65 to 90. So if it lies between the range of 65 to 90, so now what you have to do? Again, you have to do the same formula as above. You take the value, and to the value, you will add the base value. And after adding the base value, you will do some calculations, and then modify the range of the range, which is 26. There are like 26 uh, letters in the English alphabet. That's why it's 26. So you'll actually take the value, and to the value, you will add the key, and you'll subtract the base value again, which is 65. For encryption, you'll add the key, and for decryption, you'll subtract the key. else if so if the value is for the small a to z, which is I think from 97 to 122. So if the value lies in between 97, so as you see the value lies between 97 to 122. So then what you have to do, again do the same thing. You take the value and you set it to the value of 97, which is the base value. So that you will add the existing value and subtract the key, and you will add and you will subtract the base value again, and then mod it by the range, which is 26. And then for encryption it's plus, and for decryption it's minus. Yes, and now 90% of your work is done. So let's now just check out for the uppercase, lowercase, and numbers. Let's not care about the special symbols and all. And after doing all this, what you have to do with the answer, you have to add the ASCII value of feedback, so which is character value of the value itself. And believe it or not, your entire Caesar encryption is done. You can directly return the answer because answer will already be populated with the appropriate values. And yes, this is done. Let's check it out. So create an object of Caesar Cypher, and let's assign it to Cypher. And yeah, let's take a string. Let's take a text and set it to the values. Yes. Now let's encrypt the text. Cipher.encrypt the text, and let's decrypt it back. Cipher.decrypt. Again, don't try to decrypt the text. You will be left wondering where you went wrong. It is not actually text over here. It is the encrypted text. Yes, it is actually the encrypted text. And yeah, let's first check it out by shifting for one position. So now let's just print out the text and encrypt the decrypted text. Yes, now just let's run it. So Q becomes R. Yeah, it's like expected, and R became back to Q, and yeah, W became X, and yeah, X became back to W, and it continues. So A became B, B became A. So add one to A, it will become B, and then remove one from A, that will become A. And then let's do for the key of 5. Be sure to pass the same key at both the positions. So yes, Q R is to UV. So Q plus 5 is V, and V minus Y is Q. It is working properly. And now just let's check it out for edge cases. So the edge cases are 9, which should actually become 0. And then a small z, which should become capital Z. And then a capital Z, which should become your small z, which should become A, and your capital Z, which should become capital A. And yeah, let's just make it 1 to keep it consistent. Yes, 9 became 1. Z became A, became Z. Capital Z became A, small z become capital Z. That is expected. Actually, 9 should not become 1. 9 should become 0, and 0 should turn back to 9. So there is small mistake over here. Now just Let's check it out for 1 is it working properly for 1. 1 is becoming 2, 2 is becoming 1 as expected. 2 is becoming 3, 3 is becoming 2. It is there is some small bug for 0, I think. No, 0 is working properly, so there's small bug for 9. Yeah, I think it's because there are not 9 numbers from 0 to 9, there are 10 numbers from 0 to 9. That might have been the issue. Yes, that was the issue. So yes, don't make mistakes like that. There are actually 10 numbers. The range is 10 from 0 to 9. It's not 9. I had made a small logic error over there. Yeah. And as you see, it's working properly. 9 is becoming 0, 0 is becoming 9. Z is becoming A, is becoming Z. Capital Z is becoming capital A is becoming capital Z. And yes, this is how Caesar hash works. So Caesar hash, Caesar cipher, whatever you want to call it. Yes, so that's all. Thank you.